this. Oh, here you go, slideshow. Okay. Are we good?
Double check. Yep.
All right, cool. All right, guys. Thanks for coming. That's a bad day to come. I wouldn't have planned it today if I knew we were winning the championship or we were going to play in the championship. But here we go. I'm here to talk to you about AI agents, their past, where they started, where they are now, where they're going. I'm Sean Sullivan. I was in this club before, and I like making AI apps a lot. And so now I'm working on a site called LM Systems, where we buy, sell, and create AI apps. And I've noticed some things about creating them. There's some patterns. And so I'm going to go over those patterns. I'm going to go over first principles of how you can create AI apps and what you should focus on and what's going to be important in the future. And we're actually going to go through and kind of create, they're going to go through the evolution of AI apps up to from where they started to where they are and where they're going. It's pretty easy. So my framework for building agents is kind of come down to this one sentence. They need the necessary context and permissions to work effectively. And so what this means is the context is the input tokens. If you get a question, if the AI gets a question wrong, it's just like a predictor, like machine. So if you told it the answer, it would have got the answer correct. So if you put the right tokens in, you'll get the right tokens out. That's extremely important. And yeah, it's gonna be even more important as we keep going. Permissions to execute things. So permissions to do things, permissions to work effectively. Originally with like ChatGPT, the permission was just an output. There was no task it had to do. It was just send the output answer. And as we get more and more into like agents doing tasks, it needs permissions to do things. So if you use AI apps like Cursor, has permissions to use your computer, to write to files on your computer, and to do certain things. As we go more and more into like remote tools that have like, they need like API keys, stuff like that, they need permissions to execute tasks. So it's just like the basic how AI apps are, how they're important. All right, this was the OG AI app. You put the input in to GPT-3 and you get the output out. One node. And nodes are we're gonna use nodes throughout the entire talk. You can think of a node like this as any executable code, right? So this node has code inside of it. It takes an input in, takes an output out. That's all a node is. And it can be anything. It can be any code. It doesn't have to be GPT-3. It doesn't have to be any LLM. Any type of code can be a node. Something goes in, something comes out. It's kind of just like programming. But I think it's a new way of thinking how to program because now everything's being made in like nodes and edges, I believe. And so if you're into AI, you would have heard of Lisp, which is like an old, like the people in the 60s and like the 50s, the OGs of computer science and AI created Lisp. It's Lisp processing. And I think we're moving towards graph processing, graphs being nodes and edges. And so one of the big first AI apps that are pretty cool was Perplexity. This is what Perplexity looks like. You literally had the input, or the first version Perplexity looks like. The input went in, it went through a web search tool, and that web search tool sends results to the LLM. The LLM ended, it did a response. This is Perplexity. If you figure that out, this is like an $18 billion company based off that simple idea. Then they made web search into a tool where the LLM could decide if it wanted to search the web or not. It was up to the LLM now if it wanted to go to the end or call the web search tool in order to search the web. And so how does it decide if it wants to end or go here? Like we can't just take the output out and know from that. The LLM has to call a structured tool. It has to have some indicator that it wants to call this tool. I want to search the web. And so this framework of having the agent decide between the tools and the end, this framework right here is called a React agent. It means reasoning and action. The agent typically reasons, it thinks through the problem, and then it takes action. So it's like, oh, I should search the web, searches the web, and it gets a result. It's like, oh, I should search more, searches the web again, gets the result. Oh, I have the answer. Sends the end. It reasons and then takes action. React agent. This is like the most basic agent, but it's super powerful. It can go like very long ways with this one agent. And this is pretty much what all AI apps are right now. It's just this simple React agent. And so this is what a tool looks like. This is a very basic tool from LangChain, and there's a structure to it. First of all, they define it's a tool. This is the name of the tool, get weather. This is the inputs to the tool, and then this is the description of the tool. Those are the three things that matter. The name, the inputs, and the description. So this is what the LLM gets to see, and this is what the LangChain tool does. This tool indicator, decorator, parses this function, gets the name, gets the inputs, gets the description, sends it into the LLM, and says, you have this tool available to you if you want to call it. When you call it, when the LLM calls it, looks like this. Gets a tool call. This name is get weather, San Francisco. And then I get a result saying the tool does its thing, gets the response, right? Now, we're going to create a pretty simple, we're going to create an app. We're going to create an agent. It starts with an LLM and a user. User sends the LLM, LLM sends the user. And we're going to add an application. We're going to make an app on your computer. We're going to give it a read file as part of the application. So this app lets the user press in a file, and it sends it into the prompt along with the user's message to the LLM. That's our app right now. And then we can add a write file tool. So now the LLM gets the read file, can get the file and the user's message, and it can decide if it wants to write to the file. They can call that tool to write to the file. And we can also add a read file tool if the user wants to read the file again or read a different file. Then we add two more tools. We can say search through all the files on the computer, or you can use the terminal to do whatever you want on the computer. You have access to all these tools now, and we're going to send you this message. And just so you know, for the future context, the purple indicates inputs, and the orange indicates tool calls. So when a tool is called with the orange, search files, gets the response, the LLM gets the reason and action through its process till the task is complete. This right here is what I just shown you is Cursor. This is what the Cursor agent is. Cursor is the fastest growing product of all time. They hit $100 million ARR within 1 year from this one agent. This was the agent. This is it. And this is Cursor in action. It reasons, it takes an action, it reads the file, it searches through the code base, reads the file, reasons further, modifies, writes to the file. That's the entire app. Yeah, fast growing product of all time, just from that one app. And then, yeah, I guess we can take this. This is our app now. We have these file tools, and we have an LLM. We built this ourselves. It has access to our files. It's probably like a Python project. We can just run it locally. And we now have Cursor on a local computer. Doesn't look very good, but it works. We can throw all these file tools in this one node. We can call it a tool node, just for the sake of calling it. All right, we call it a tool node. This is our app now. The user sends an input. The agent calls the tool, gets the tool response, and when it's finished, sends the output to the user. This is the reason action agent still. This is how you call a tool still. And yeah, how do we get it to, let's say, what do we do with these file tools? Let's say we want to move it to the Claude desktop now, because that's an app on your computer that has access to your computers, has like permissions to use your computer. And how do we get these file tools, tool node, access to Claude desktop? You would do this through an MCP server. MCP, Sebastian's going to talk about more later on, but I don't know if you guys are going to go to that meeting. And I'll talk about it a little bit in this meeting because it's pretty important now. It's kind of, the way you can think about it is it's the routes. This is MCP. This is the reason there needs a MCP to connect your file tool node to an app like Claude Desktop or to future other apps too. So we're going to make our file tools into an MCP server, and we're going to have Claude Desktop have access to be able to use those tools, hypothetically making Claude Desktop into Cursor in some ways. We're going to make it into the MCP server. But we can't make these tools into an MCP server because these tools are LangChain tools. We need to make them to MCP server tools. MCP server tools are like this. They, instead of having a code function and parsing it, you have to actually say the JSON of what's going on. So you have a name, description, input schema, the same thing we care about in the LangChain, name, description, input schema. Luckily, there's a file system MCP server. So if you actually want to do this, you'd have to make your own. You can take the one existing. And yeah, taking existing one is pretty cool. Okay, so now maybe we're using the file tool MCP server that already exists. We didn't have to create our own. And we have our agent from scratch pre-plug into Claude. And we've replaced this with the MCP server. We have the agent that has access to it, and it works the same way. MCP servers work like this. So you put a start, you query Claude, and when you connect the tool node to Claude, it has this function called list tools. This puts the tools into Claude's system prompt, and saying you have access to all these tools. Claude then knows when it gets the message that, hey, I can call this tool to do this thing. It gets a response, and when it's finished, it can send to end. That's just how MCP servers work in general for like the client side, so the application side. The problem is that when you use this file system tool, there's 12 tools there, and there's 12 names and pretty lengthy descriptions and input schemas. The problem with that is if you have a general agent like Claude, and you want it to do a task, and you have these servers active at all times, it's going to probably get questions wrong because the input tokens going in are probably 20 or more tool descriptions and names that aren't necessary for your question, every question. So passing this in every single query is going to mess up Claude, its performance. So right now, people are plugging all these tools in at once and activating the server, and then Claude has access to that server. But I don't think that the general purpose AI agent of the future is going to have all the tools available. It's not going to have hundreds of tools available to it. And I'm going to explain why. Because what I found through building apps myself, and we have an MCP server store at LM Systems, which is a bunch of API calls. What I found is that it's better to have an agent that calls tools, like have an agent call a different agent with tools, rather than having one general agent call tools directly, for that exact reason of listing hundreds of tools every single query. It's better to list 10 agents that have 10 tools each, rather than putting 100 tools in. And so that's like pretty obvious, and it's more performant, just in general, because it's specifically system prompt is for that specific thing. So it's gonna be better. And so we have our agent with the file tools. And the cool thing is that since there's an input and output to this agent, to our agent right here is one input in and an output out, something happens in between, we can turn both of this agent and file tools into a single node. So something comes in, something comes out. And we're going to do that. So now this is our application. This is it. And we're going to test it with a different LLM. So we're going to have this agent be able to call these tools, and it's going to return a response. And this tool call will look like this. File agent, you give it a file path. It's now on that file path of your computer, and you ask a question. It's going to go in, and it's actually going to be our agent with the file tools, give a response, and work until it's complete. And that's inside of it. It's going to call a readme tool or something. And yeah, work like that. Now we can turn this agent with the file tools into an MCP server, plug that MCP server into Claude. This would be better than the file system MCP because it has an agent specifically made for the file tools, and Claude now has access to it. And so instead of having 12 tools, Claude now has one tool. This is the one tool. And this one tool has 12 tools under it, right? And yeah, instead of having these 12 confusing tools. So now we have this. This is pretty cool. Now we have Claude Desktop with the file tools agent. They can use it whenever it wants. That's pretty cool. What you could do, this is kind of crazy, but if you follow this track, sorry, yeah, you can go.
Is there a preference between choosing models for a file tools agent versus the calling agent?
For any tool calling agent, I usually, if you want to use the best model, I would use Sonnet, Claude Sonnet. Claude Sonnet's the best model for calling tools. Is that what you're asking?
Yeah, but I'm saying like the file tools agent versus the actual agent calling the file tools agent. Like,
Right. So Claude or the file tools agent.
Yeah.
What about it?
is there a difference between when you want a model for the file tools agent versus a model calling the file tools agent?
I don't know. I mean, so in this case, you would have the Claude app on your computer. Whenever you ask it questions, it would decide, it would reason if it should call this tool or not, the file tools. And so if you asked it to modify a file, search files, do anything with your files, it would call that tool. But if you asked anything else, it wouldn't call the tool.
So it's the same model.
Same model, but different different context, different input tokens for both.
I was just model. You want like a smaller model maybe for the file tools.
You could use smaller model, but I would use Claude Sonnet 3.7, the newest one.
Yeah, generally you don't want to use a smaller model.
I mean, you could. It depends your task is. So like if your task is like summarizing, I would use a smaller model. If your task is to modify files, I would use the best model available, because that's like a higher IQ thing to do, higher IQ task. If you follow this method with different API calls, so this one we're using read files and like search files, stuff like that, you could hypothetically create a single node that has all the tools of a database and gets inputs in from the user interface, calls the database and gives a response. And if this LLM was instantaneous, like some Grok models are, this could replace the entire backend industry of like software, which is kind of crazy. Sebastian.
For calling databases, you're suggesting.
Yeah, you can have this as your backend. It's possible. We're going in that direction.
Yeah.
This is an out there. That's an out there thing.
Definitely help out. What I was gonna ask is like you're suggesting basically delegating the tool call, like a couple slides ago.
Yeah.
What is your intuition on like when you should like delegate tool calls versus not? Because I know it's like multi, like every LLM call, higher probability of failing.
For me, it's like general agents. So like when you have a general agent like Claude Desktop that you want to have the servers or the tools active at all times. So you would want to have an agent as the tool caller, as a delegator for tool calling, because this agent uses the same model as Claude. They're both Claude 3.7. But this one is a system prompt that says you have these tools, you're specifically made for the file system. Your entire purpose in life is to modify these tools. Claude's purpose is much broader. You want to narrow the purpose as much as possible. You want to have the best input tokens possible for the best output tokens. That's the logic. What's possible in the future is that since the nature of MCP servers, with the listing tools, what's possible in the future is that you could have some logic. This doesn't exist yet. You could have some logic that decides which tools to list. And it could be, imagine all the tools ever to be made. And there's like a search engine that searches on the best ones for this query. It pulls those in for each query. That's possible in the future, but that does not exist yet.
Yeah, it's like graph neural networks. Should get Google on.
Yeah. Okay, so now we have Claude Desktop. We have our file tools MCP. We can add on a deep research MCP server. The MCP allows for plugging and playing of, if Claude Desktop's a client MCP, which it is, which means it accepts MCP servers, you can plug in any MCP server into that client, and then has access to that tool. And deep research in and of itself, it looks like one node right now, but underneath the hood, it's like an entire graph that is pretty complex. And like, you would rather buy this than build it. You'd rather take the best available option in the market than build this from scratch yourself, because that would just take a lot of time. Yeah, and this is like, has subgraphs with inside of it. So like even this node right here is like 4 steps. And so what we're seeing is that we went from one node to like nodes within nodes within nodes. And what we're seeing is that this is an ongoing trend of like agents talking to agents. And that thing again is pretty important. And so we can take this even further. We can take this out of Claude Desktop. We can take our 2 MCP servers. We can plug this in to our own LLM that's an MCP client and has access to both these servers. This is just a normal LLM and says you have access to both these servers, accomplish the user's task, with these tools until it's complete. As we know, both of these nodes, these tools, have a bunch of things going on underneath it. And so what we could do is we could then bundle this up into its own node and call it coder. And so this agent's task is to code for you, and it has access to the best research tool ever. I guess you can do open deep research with ChatGPT or deep research with Perplexity, but yeah, it's a great research tool, and it has a file tool, so it can modify files on your computer. We can bundle this up into its own node called Coder, and we can then add another LLM that has this Coder as a tool. And so now this different LLM has that entire graph as a tool available to call it whenever it wants. And what we could do is we could make a new, imagine the equivalent of Coder, and we call it Tester. And Tester runs the code that was created. Imagine it can like see your computer screen, maybe control your computer. They can see the outputs, test the code, and send the output of the debugging. The supervisor tells the coder what to fix, what to do differently, and it goes in this loop of code. This closes the loop of coding until the code you want to code is complete. And when it's complete, it sends the end. You would imagine this would be like a small to medium-sized task, and you would imagine that Tester would be a pretty complex application in and of itself that would run the code, maybe take screenshots of your local browser, testing your website or whatever you're coding, and sending the feedback to supervisor. Supervisor plans it out, tells the coder, then it goes in this loop until it codes the thing for you. And then you could bundle this up. I'll take questions at the end. And then you can bundle this up into its own node called Coder again. And then what you could do is you could have 3 of these things run in parallel, and you could have an agent sent to a planner that has each coder take each step of the plan, and then each step is handled by a very complex graph underneath that then codes the thing for you. This would hypothetically allow you to say, I want an iPhone app that does X, Y, and Z, and it codes it for you without you having to do anything. I'll take your question.
Because a lot of these steps, you have a lot of integrated model calls. And I'm assuming there's token consumption as part of the communication. How significant is that communication going between the models?
Between the models? For what? What do you mean?
Like token consumption.
Oh, token consumption? Not as significant as you'd think, but it would cost a good amount of money. But this is the idea behind like AI coding. If it actually worked, and if you actually had a pretty good tester, it would probably cost like $20 to make an app. That's a lot for tokens, but it's not a lot for a person. Sorry.
So I guess, yeah, the tester is good because you're stopping, I guess, like the error of the LLMs from cascading from each.
Yeah. Yeah. Because what I've found is that, well, I guess through like researching and coding with Cursor in general, is that when an agent gets something wrong, when it thinks it's when it gets something wrong and it generates an error in the code, generates bad code, if you keep going in that conversation, saying fix this error, it's going to keep having an error. You have to go before the error was created and refix that prompt. And so I would imagine that this application would allow you to do that. And the supervisor would be able to go back in time to before the error and fix that. But the tester, for closing the loop with coding, tester's necessary. A really good tester is necessary. And there's not really a good one on the market yet, but there will be. A big company does this for sure.
It's interesting because like RL, you have like the actor critic method. And you have like that same concept of like, I guess, a coder being like some actor in the environment, and the tester being the critic, telling how good it's actually doing.
Yeah. There's like reward functions too and stuff. It's pretty cool. But I think like AI apps with LLMs is less technical and more just like throw it at it and see what it does.
And have you seen like losses, I guess, or like errors cascade?
Yeah.
Urban agents. Like,
Yeah. And
a rough like guideline. Don't do this or do better.
I think the easiest way to prevent that is to have better plans, to spend more time on planning. So like to create like the perfect input prompt, and like there's a perfect size of like task. I mean, there's never too small of a task, but there is too big of a task. If you give it too big of a task with not a too vague of plan, it's going to get it wrong, or probably get it wrong. At some point, get it wrong. And so there's a sweet spot of the size of task and the amount of research done and specificity. Yeah, but right now they do get a lot of stuff wrong, which is why a tester is needed, and it's also why a supervisor is needed to ideally, maybe that's the planner, supervisor the planner of some sort. But also that's why this agent would probably make a plan into steps, and this would come out. It would just like do it. It would probably run these three in parallel with differentiated steps that aren't related to each other, because a lot of coding is related to each other. Maybe we do it sequentially. I don't know. But what I'm seeing is that there's like a flow to making agents, and they're quickly compounding within each other. So like you see these, like there's what, 6 nodes on here or 5 nodes on here, but in reality there's like 100, right? It's like all underneath compounding. And so I guess the way to think about this, and this is like where everything's going, there's gonna be low-level agents, mid-level agents, and high-level agents, and they're just they're quickly compounding. And I think let me just go here. This is happening pretty fast. And a good way to think about MCP servers is they're a standard way of communicating between agents and plugging and playing different pre-built tools and pre-built agent nodes. And I think a big thing is going to be MCP servers going to be agents. Right now, they're all like tool calls, API calls, traditional tools from AI apps we were building 2 years ago. But now they're turning into, it's much better just having them be agents. And one more note that's kind of a side note is that the remote versus the local MCP servers and agents in general, because now they're kind of converging. Whenever you're building an AI app, you have to think about like, you have to really think about if you want to do remote or local, there's like trade-offs for both. Local is definitely more powerful because it's control of your computer and your file system, but it doesn't scale well. People that download an app probably, or with MCP servers, you currently run the server yourself. Like it's kind of technical, like a non-technical person probably couldn't do it. And remote applications are better for like retrieving information. So deep research would be a remote thing, and it scales and you can easily distribute it through a website. Very easy. And then the last thing I'll say is that there's some opportunities here. Local MCP server, there's a lot of issues with MCP servers, but it's become the winner for like how to communicate with large apps. So our ChatGPT is adding it like next month. Claude's out already. Every AI app's already added it. And it's kind of turning into like the app store of AI apps. Because if you have one of the nodes in the final AGI app, you're gonna be pretty rich. And so those nodes are probably gonna be MCP servers. And so some opportunities are building a local MCP client app with computer use. I think there's gonna be an application you download a computer that can use your computer and has MCP client compatibility. So remote servers can use it to retrieve information, and it can use your computer to do tasks. And then some other cool ones are you can't really run local MCP servers if you're non-technical. So having an application, you can easily turn it on and off. It's pretty cool. And then also any like software task you to do, if you just build it like an agent one layer above to do that thing, or an agent above like an API like Supabase or something, that's a big opportunity if you are that one agent to call, because it'll be better than just calling the API tools directly. And then also figuring out authentication for agents, remote tools. That's a big issue right now. If you build applications at scale, you'll know that you don't want your users passing in API keys. So if you figured out a way to fix that, you'd become a very rich person. That's the talk. That's all I want to talk about. Yeah. Let's go. Questions.
What do you think of low code agent development?
Well, I'm not really into them, because the issue with them is that the company who makes them, or maybe they're converging, but the company who makes them has to create each integration manually. And the reason developers code with code is because like the limits are like there's no limits. You can create any integration you want. It's like a blank slate. I think it's going to turn to describing what you want with words. And maybe I think it'll be through the form of like, in the browser is probably the best way. And you would say what you want done. And then the node would make that code for the node. And then you could like, yeah, I think it's going to be, you're going to say what you want. Kind of like Cursor, but in a more organized way, maybe a more visual way. I'm trying to build a similar thing. If you go to the Canvas and LM systems, that's a low code way to do it. But the low code I did isn't like NAN, isn't like Zapier. It's like you say what you want and then we have an AI code it for you.
Did you showcase it?
No,
You should. I mean,
I made
it's a
it.
big reveal. A lot of these slides are created.
It's not a big reveal, but This-
It was so clear.
this is kind of how I imagine it. You have an agent. This is my like low code thing. You say this agent is an OpenAI agent. And then you just have that create the code, and then you make the flow of how it would go. And then this thing codes it for you. But I should probably make it better. I finished this yesterday or 2 days ago. So yeah,
Did you work on?
and it's broken. I worked on it for like a week, maybe 2 weeks. But yeah, it's not, I haven't tested it very well. As you can see, it's not working right now. But it should be making the code.
So this is a good point. How do you evaluate it?
Hmm?
How do you evaluate the performance?
Well, I would, so whenever you make an agent, you have a use case in mind, right? And so you would run it locally. And yeah, this isn't working. But the point is, it makes the whole file system and like the graph, it does the whole code for you. And I'm gonna add a button where you can just deploy it once with one click, and they're all MCP servers out of the box. So whatever you make here can be used in ChatGPT and Claude soon. But for evaluations, that's why I like LangGraph a lot, is because you can run it in their studio, which is a great studio. Do I have a tab pulled up? No, I don't. And then each run you do, there's traces of it. So whenever you make an AI app, you want to have traces. There's a lot of libraries to trace, but I like LangGraph the most. And they have tracing, and you can just create a data set of your traces, and you could create evaluations that way. That's pretty cool. That's what companies are doing.
Create evaluations. What do you?
So you have like a list of questions you want to do. And I guess you could use the SDK of the LangGraph SDK for your deployed application. So you create an AI app, you deploy it, or you can run it locally, and you use the SDK on your list of questions, list of use cases. And then you just automatically have that run, and you take that data set and you just look it over, see the outputs. Did it work? You know?
And you're seeing them over Langsmith or?
Langsmith. But there's a lot of other tracing things. I don't want to be biased towards LangGraph, but I am. So yeah, that's how I kind of think about low or no code things. I think it's I'm not the best. I did this myself, so it's not the best. But I think if someone really smart made this, and there's like a way to say what each node did, because I kind of visualize, it's a very visual thing. I think that's gonna be the way to do it. And I made it in the browser, but I think making it local would have been better. But I built on top of an open source project that was built on a TypeScript, which is like a browser-based language. And yeah, I kind of regret doing that. I wish I did it locally, because then you can just run the code locally on your computer, and you can add tools that like have your file system, which is super cool. And yeah.
I don't understand like the whole like remote versus local.
Yeah. Okay. So
What did you just like give the remote system access to your local?
but you can't really do that for a few reasons. Well, I guess one of the reasons would be testing. So let's say I make the file system app and I deploy it remotely. Deploying it means to a server like AWS, to the cloud. And so that means anyone else can use that as an API, which is very nice. The issue is when you make it and you have it run locally, the code you run to have it run locally, there's like in Python, you would use something called subprocess. Subprocess means you can use like your terminal. When you have something like subprocess, use your actual terminal. So when you run the code, use your actual terminal, and you deploy that to the code, it then uses the server's terminal, not the user's terminal, right? And so it's going to run locally on the server, and that doesn't help the user at all. It's just like running in the cloud. And so it would be more for testing development. you would have to have like a remote coding sandbox. It's like a remote machine that then like simulates an actual computer, and you have to upload other files to that actual like cloud computer, and then have it edit the files in that cloud computer. Like it can't edit your files locally if it's a remote based thing, unless you had an application that had access to those files. So again, to like the permissions thing, it would need permissions to those files. You can't do that through straight up an API. It would need an application of some sort on the local computer. So I just mean like app wise. What is it, like an API, or is it like an application on your actual computer? Yeah,
But if it's an application on your local computer, then yeah, you can have,
right.
yeah.
Yeah. But if you want to make an AI app, it's like, if you want to make an application on a local computer, that's like a whole front end thing. It's a whole, you have to market it and sell it, people to download it. It's much more difficult. You could do it through the CLI, which is what Claude Code did. They chose to do CLI because you don't need to do a front end and stuff. And it distributes pretty well, and it has access to your local file system. But yeah, you can't, like ChatGPT can't control your files unless you upload it to ChatGPT, right? That's a remote thing. So yeah.
I think you might be able to get away with GitHub Codespaces, with GitHub.
Yeah. I know. So I'm gonna upload the button's gonna be, you can run it locally, like right here, and it's gonna go to code spaces, and then I'm gonna get the endpoint, and we can like run it through here. It's pretty cool. And I didn't make this better. I didn't make it very good. But if it turns out pretty cool, yeah. And who here is a software engineer? Like what is your guys' majors? Everyone software engineer? Electrical engineer? That's pretty cool. Is there a lot of I'm showing a lot of graphs. Is there a lot of graphs electrical engineering? Or like this kind of canvas thing with like these nodes and edges? Yeah, circuits. It's kind of similar to like a computer, right? It's pretty weird. I feel like LLMs are kind of like microprocessors a little bit. And then there's like in AI apps, there's a lot of vector stores and databases for memory, and it's just RAM. It's pretty cool. And I think if there's like a correlation between LLMs and microprocessors, I think like we're at the calculator stage. I think like there's gonna be computers made with like in this way, but right now we're just making calculators. So yeah, pretty excited.
How did you learn?
Do more. That's the truth. I'm not a computer science major. I didn't take any coding classes. I just want to make money online, and then you start building stuff, and then you realize you know nothing, and then you just want to learn. That's what I did.
How long do you think this would have taken you without AI?
I can't go without AI. And before AI, I hired contractors, but now I can do it. Now I don't have to wait. Yeah, now I'm
You
the,
don't think it's a thing that you, like, it lets you learn about coding, or you just like, you just vibe it out completely?
I don't really vibe it out. I kind of go hard with it. And I'm making things to go even harder, where it's like, I kind of want to make an app where you can like, it can control your computer, it can control cursor in parallel and do it like multiple times. And actually I have an app that's an open source app that does that. And I'm gonna try to build on top of that. But it's kind of like doing math with Excel. Like, okay, I'm not really good at physics, but I can like do the equations, because if I'm relating to using cursor for coding to doing math, and like having cursor. Right, I know what's going on, but I don't do a lot of the hard thinking, and it's a lot easier. A lot easier, but the issue is you run into a lot of errors, and it kind of drives you crazy. And so that's why I've learned the prompting is really important, and planning is really important. So I plan for like over half the time, and I make the prompts for like over half the time. That's like literally all I do. Yeah.
What is general guidelines that you say for prompting?
I used to use this template for prompting that does like a high level over objective of what you want to create. And then it does like I kind of spit out my words in the middle part, mid-level objective. And then I go step by step through low level tasks. And that's much better for like, and then what I do is I throw that into Claude Code and I say, look at this plan, and then look at my code base, and then create a different plan for that plan based on my code. And I throw that plan into like step by step, the first step of that plan into Cursor. So I have Claude Code create like a 5-step plan, or whatever, how many steps it is. Claude Code is, actually, I'll just show you this thing right quick. This thing's very cool. This is Claude Squad. Claude Code is this. Can I run this? It's a CLI tool for coding. So if you say Claude, it can code for you. Yeah, this is like kind of cursor in your browser. Then you can say edit this file and edits for you. But then what you can kind of do is this has two Claude Code things run in parallel. You could add more and more and more. And this should be an app on your computer. And then you can have Claude Code, which is a CLI coding tool. I think it's kind of better than Cursor at coding. And you could have multiple of them run in parallel. And then you could like do this remotely in the remote sandbox. And then you could make an app on your phone that says code this app and it codes it for you like I showed. And that's going to exist very soon. Like even like the Replit agent, like the best agents in the world are pretty simple. Like based on the diagrams I showed you, they're kind of not very complex. It's just brand new. So there's nothing to really base it off of. So they take a while to build and they say it's really fancy, but it's not that complex really. Yeah. I'm excited for the parallel agents. Yeah.
Why would you want parallel agents?
Do more
But
faster.
you're giving them the same question. Wouldn't they be colliding?
I don't know. So you would have it, ideally you'd have it run without you. So you'd have and you'd automate the planning step that I said. You would say your high level plan, and then you would have agents plan the code out for you. And then it could give out the tasks that aren't correlated in parallel. And it could like order the other tasks that rely on sequential. Yeah.
In parallel, where you could have like, two agents working at the same time, but maybe you separate the code bases.
Mhm.
So there's no conflict.
Or if it's like different files and stuff. Yeah. Yeah.
And then you create a diff file, and you have an agent, a third agent, then evaluate that diff file.
Yeah, you could do that. Could do that. I think testing and evaluating is going to be a whole entire agent field similar to coding. I think there's going to be like a Claude Code for testing and for debugging. It doesn't exist yet, but it closes the loop for coding. And I think something to note is that the coding agents are the biggest killer app in AI is coding right now. But maybe that's because everyone that builds AI apps is like coding, so they're solving their own problems. It's like the closest use case to coding is me solve first. And I think the furthest use case from coding is be solved last. And I think if you find like step 3 or something, like over here, that's a good use case if you want to build an AI app. That's pretty cool. I think education is a really good use case too. Education is a great use case.
How is that? So what I'm imagining, this just seems like ripe with conflicts. Like, if I were to like create a task, update my front end page, and it's gonna delegate like one guy is gonna like take care of the copy, the other guy's gonna take care of the formatting arrangement. I imagine there would be a lot of conflicts between the two agents.
Probably for editing files, probably. I would do more for planning files. Imagine like a markdown file for each folder that explains what the folder does, and you can throw that into context for Cursor. That'd be pretty cool.
I'm thinking of a very similar story. I think it's very similar issues. If they're using different resources, then like I was talking about with the planning is independent of each other, and they can test it independently.
Yeah, could have been funny.
Then they wouldn't conflict with one another.
A lot of tasks conflict, but some don't. A good amount don't. And so you could, there's some things you can do. Yeah, that is my talk. Thanks for coming to my talk. TED Talk.